Welcome back. Today we are going to be talking about functions and their graphs, and we're going to start by discussing function notation. So let's just start our discussion here with an example. Here we have a function f of x, and I picked a quadratic function, so f of x equals negative x squared minus 2x plus 3. So let's sort of understand and unpack what all of these symbols mean here. This letter f right here, that's the name of the function. So f is what the function's called. So I mean, we could call our function f or g or h, or we can pick any letter we want, but this first letter here, that's sort of the letter that we're going to use for the name of the function. So this is function f. And then this right here, this letter in the parentheses, that's sort of our variable. And really it's our input. So the way that you would read this is called f of x. And the way that this is going to work is that we can choose numbers for our input value, x. And then the function is going to return an output value. And the number that the function returns depends on the rule, depends on sort of what the function does. So we're going to talk about how we can get outputs from given inputs when we look at sort of the algebraic representation, when we look at the equation, and then also when we look at the graph of the function. So this picture, this sort of red parabola here, all of the points here in red, those are all of the points that lie on the function f, all of the points that make up the function f, so to speak. So let's do some examples where we're evaluating using our algebraic representation here. So let's figure out here, what if we wanted to have an input value of negative 2? So we would write this as such. So this right here, the way that you would say this, so how you would pronounce that, that's f of negative 2. That's sort of how you would say that. So negative 2 is our input, and then the function f is going to output a number based on our rule here. So the way that this goes is I'm going to replace every x that I see with a negative 2. So instead of writing negative x squared minus 2x plus 3, I'm going to write negative 2 squared minus 2 times negative 2 plus 3. And when you make your replacements, use parentheses. So see what happened here? Instead of writing x, I wrote negative 2. Same thing here. Instead of x, I wrote negative 2. Notice this minus sign, this squared, some exponent, this 2, this plus sign, this minus sign, this 3. Everything else stays. I'm just replacing x with negative 2. And now I'm going to evaluate all of this right here. I'm going to find the value. When you're evaluating something, when you're evaluating an expression, that just means you're finding the particular value. So now this is just an order of operations issue. So negative 2 squared, that's negative 2 times negative 2, which is 4. So I've got negative 4. And then now here we've got negative 2 minus 2, that's positive 4. It's 3, so this all looks to work out to be 3. So I can conclude that f of negative 2 is 3. So that means when I input negative 2 into the function, 3 is the value that the function outputs. Negative 2 is the input, 3 is the output. Negative 2 is the x value, 3 is the y value. So how could we corroborate this by looking at the graph? This is really nice when you look at the graph, because if I want to evaluate f of -2, well, I need to look at when x is -2, what is the y value for the point that is on the function that has an x value of -2? So I would go over to an x value of -2, that's right here, and then I would find the point on the graph that has an x value of -2, and I would look for what is the y value of that point. That's 3. So evaluating functions using a graph is really nice. It's pretty convenient, because I can just look for that x value and then find the point on the graph that has that x value, and then find the y value of that point, which would be 3. You can also sort of mix up this game. Like, what if I wanted to ask the question, so what if I wanted to ask the question, f of what value will give me 4? So notice what I'm doing here. I'm sort of playing a different game. I don't know what the input is. I'm looking for the input. I know what the output is. The output is 4. So I know the output. I know the y value is 4. I'm looking for points on the graph that have a y value of 4, and then I'm trying to figure out, well, what are the x values of those points? So let's find points on the graph that have a y value of 4. There's only one. That point right there has a y value of 4. That's the only point on the graph with a y value of 4. And what is the x value of that point? -1. So if I was trying to solve f of x equals 4, if I was trying to find the input that will give me an output of 4, that input is -1. So basically what I'm saying here is I'm saying that f of -1 is 4. And you can check that. The x value is -1, the y value is 4.